and welcome in today's video. Today I'm going to solve the previous questions which is solved by hand calculations using AutoDesk Robot software, and in the end we are going to compare the result which we got by hand calculations and the one which we have by the software, just to make sure that what we calculated by hand is correct and it can be used in the future if someone wants to solve this type of problems parametrically, and they can take those values immediately from here. So this was the beam for which we assumed some dimensions and some loads, and we solved in the last video when we did the hand calculations. And now I will provide a step-by-step modeling process on how we can do or how we can model the question which we solved by hand here in Autodesk Robot software and make sure that the results are correct. So without any further ado, let's create a new model. We are still on the 2D model. And if we go back to the problem itself, let's just quickly check the values for which we assumed. Yes, so we have A and B, it's equal to each other. So this is A and this is B. And the dead load or the distributed load which is acting on the beam was decided to be 3 kilonewton per meters. So the first thing to be done is for us to determine the members. So A and B were 3 meters. So let's go to members and assign a new member. Let's choose, for example, this type of profile, and let's start to draw our member. So let's go to the point 0, 0, and we had that A was 3 meters. Now we go to 3 meters and we right click on our mouse. So we have the first part. Then we click again and we go to 6 meters. So now basically we are going to have our 3 meters bars as it was given on the task. So the next thing after we define the members is to define the support conditions or to add the supports in order for our structure to be stable. We go here to the support options, we click, and according to the problem, if we go back, we had the pin here and a roller here. So we go to pinned support, and this is going to be the configuration. Then we select node number 1. So we already added the pin support, and we have to add the roller here at the second node. We click or select the second node, and now our structure is going to be stable. So before adding the load, we need to create a load case, and we just go here to load types. Let's just say that it's a dead load. And now we're going to add a 3 kilonewton meter distributed load all along the beam. We go to member load and we choose uniform load, and it was 3 kilonewton per meter. Then we substitute here -3, and then we just select the members where we want this load to be applied. And then we close this. If one wants to see the value and the load, they can press these two options here. And now we can see that our distributed load is successfully added to the beam. Next, if we run the analysis, this is going to take into account the self-weight of the beam, but let's say we don't want that. We go to the loads and we just delete this one, which contains the self-weight. And then we go again to the start, and now we just run the analysis one more time. We have the results available here. So next we show the results which we want, and actually we want the deformation, but before that I would rather have these parameters on always. Then we go to the deformations and then we just hit normalize, and as you can see here at point C we are going to have that the displacement is going to be 70 millimeters, which is exactly the value which we got from our hand calculations. Also, we need to check the rotation at point A, and in order for us to do that, for example, we can show the nodes, and we have node number 1, node number 2, and node number 3. We can just select node number 1, and we can go to tables, and we can choose this option, nodal displacement, and table filter to a current selection, which is going to be node number 1. We hit OK, and then we are going to have the values for node 1, which is going to be minus 0.004 radians. And this value seems to coincide with the one which we got by hand calculations and shows that our formulas which we derive by hand are safe to use and they are correct. Also, if we want to check the displacement, we just add node number 3 here, and yep, we're going to have this displacement of minus 70 millimeters downwards, and the rotation at this point is going to be 0.027 radians. So this concludes today's video. I really hope you enjoyed today's video. If there is any questions, please leave them down in the comment section below. Thank you very much. See you on the next video.